So, good morning, everyone. I'm Evan Fernandez. Janani ma'am has given a basic overview of how CFD is and in open form what to look for exactly. So, I'll just go right through this. So, just an outline of what we'll be seeing in this hands-on session. So, most of you now, Janani ma'am has given you a overview of what CFD is. So, this is quite clear. The applications also are quite clear right now. So I'll just give you a brief overview of what OpenFOAM is. So OpenFOAM basically stands for Open Field Operation and Manipulation. So it is basically used to solve CFD problems, but you're not restricted to CFD itself. You can go around with doing many types of simulations with it. And it was developed by Henry Weller in the late 1980s at the Imperial College of London. So it was first made as a foundation version. So you will have the basic OpenFOAM 1, 2, 3. Those were your foundation version. But in 2015, the company, basically what the people who are running OpenFOAM, they have branched it out into a foundation version and a .com version. That is basically you have the ASI version. That's why you have in the later versions, the basically OpenFOAM 2412, 2406, 2212, that way. So the main difference between both these versions is that the foundation version is basically they don't get too many updates quite often. And the ESI version is frequently updated after every six months. So you will have some new post-processing utilities or some new solvers that are introduced. So like if you see in OpenFOAM 9, you will have a set of solvers for your basic problem. Like if you have to do some supersonic flow, you're restricted to solving certain equations only. Whereas if you go with the .com version, you have a variety of types of solvers that are more stable compared to the foundation version. So there are a bit pros and cons of each of them. So you can look at it accordingly. It is widely used, OpenFOAM is widely used in academic and industry. So as ma'am said that in case you have some preliminary simulations you want to run, running it on a commercial software would be quite expensive, and you might not know that whether that project is going to go into the next phase or not. So OpenFOAM is like that, how you say, like cost effective as compared to commercial solvers, so softwares, and it is ready. There are readily available solvers. So if you have any specific problems in which you want to tinker with the equations, or you want something that will solve the equations according to your needs, so you can create your own solvers as well. So you can modify it as and when you need. And there are some important fundamentals you need to understand of CFD. That is your mesh generation, discretization, solver algorithms, everything. So now you've understood the background of the equations, how the equations are solving, how to connect the dots. So now we'll go to the process of CFD. So first you have your problem definition. So depending on the problem, you're going to go about it. So first you start with the problem definition. According to your problem definition, then you go into the next step, that is your geometry and mesh creation. Within this, you will basically see which part of your problem you want to compute. Like if I have a long pipe and if I want to compute only one section of that pipe, so I will create a geometry and a meshing domain only of that section. I would need to compute the whole pipe. Once you're done with the meshing, then you move to the solver selection. Which set of equations you want to solve, what is your end goal, what you want to find out. Once you're done with that, then you go to setting up your boundary conditions. Now keep in mind, setting up your boundary conditions is quite important. Otherwise, you might not get proper solutions and your solution may not converge. So those comes to the next step, that is your solutions and convergence. Once you're happy with your solution and it is accurate enough, then you go to your post processing. If in case you want to find out some additional things from that simulation itself, like if I have an airfoil and I'm doing a simple flow over an airfoil, I've got my simulation result and everything. It's computed, converged perfectly well. And then I want to do some post processing of, suppose I want to find out the Strouhal number of the frequency shading of the vortex shading behind that airfoil. So accordingly, I can do those post processing utilities. One good thing about OpenFOAM is you can use Python or you can use any other softwares to write your custom code to compute something once your simulation is done. So now if I haven't, now I'll take the airfoil case. If I have that airfoil and through the simulation, I am getting some forces. Say I'm getting the pressure and viscous forces and all those. So through that, I can write a custom code in Python to find out the frequency, to find out the vortex shedding that is happening behind the airfoil. Along with that, I can also find out the coefficient of lift and drag all at once using the post-processing utilities. So some important things are now in case your solution, so it's not just a one-way thing, like you start with your problem, then you move to your geometry and then you're done with it, everything that way. So in case your solution isn't great, so you have to come back again to your, in case your mesh is not good enough, so you have to come back to your mesh and then restart the whole process. Again, if in case your solutions are not according to how you require it, then you have to go back, you have to check your boundary conditions. So there's a lot of, if in case you are starting a new problem in the beginning, there will be a lot of trial and error. So it is good that you make errors so that you learn better. So as ma'am said, this is the case structure in OpenFOAM. First, you have your zero folder. Now within this, you have your initial boundary conditions. That is everything that is set to zero. You specify your velocity, pressure, or temperature. If in case you have those, then you come to your constant folder. Now within this folder, you will have all the properties that are constant during your simulation. That is your, suppose you have your density, if in case it is constant, so you will specify that. Any fluid properties that are there, those will remain constant throughout the simulation. So those are kept within your transport properties or your turbulence properties in case you're adding any turbulence. So those files can also be added. And lastly, the most important folder, that is your system folder. Within this, you will have your block mesh dict. This is where you will specify certain set of points to define your domain and to mesh it. Within, after that, you have your control dict. This is again controlling your simulation, your start time, end time, after how many time steps you want to write some data, how many sets of data you want to write, how much you want to delete, all those parameters. Within the control dict, you can also specify any post-processing utilities. As I mentioned, if I want to compute the forces or the coefficient of lift or drag, certain things like that. After that, you have your FV schemes and solutions. As ma'am said, these will basically say, these are the things that will solve your equations, how much relaxation factors you want to set, those all things. Now we will move on to the first step in CFD, that is defining a problem. Okay. So for this particular case, we've taken a simple cavity case. And now in this is a simple block, a single block used in, we are doing it by using block mesh. Okay. So this is a single block. The three sides, that is the left, bottom, and right, are walls, and the top wall is set to be moving. So we have a moving wall with a constant velocity of 1 meter per second. Okay. The whole domain is around 0.1 meter, and this is in your X and Y plane. Okay. So first of all, we will start with setting up the case in OpenFOAM. So this is a follow along session. So I will go very slowly. If in case you have any doubts or anything, you can unmute yourself and stop me at that point. So I will go back to any of the problems that you have. Okay. So first, let's open a terminal. You can open it through Ubuntu. If you're on, I guess most of you are on Windows. So I will go about using this thing. So I've opened my terminal. Okay. Has everyone done this? A simple yes or no will also do.
Yes.
Okay, great. So in case any of you are using multiple versions of OpenFOAM, so you will have to call the version. In case you only have one OpenFOAM, that is OpenFOAM 9, you don't have to do this. So now I have multiple versions, so I am sourcing OpenFOAM 9. So once you're done with that, within your terminal, you can type cd $foam run. Okay. So what this will do is it will take me to the run directory that we've created during installation. All of you must have created a run directory during your installation. So by typing cd $foam run, you're going to enter that run directory. Has everyone done this? So the very first thing we'll do is we will make a directory so that we can run a simulation within the run folders. We don't have multiple files just lying around. So we'll make a folder of say cavity case. Okay. So I will type mkdir, that will be making a directory, and I will type the name of the directory I want. Mkdir case, or I'll say cavity case. Okay. So once you're done with this, you can type ls. So now you see in my run directory, I had a previous folder called me412. Now there's a new case that has been created, cavity case. Okay. Has everyone done this?
Sir, what is ls command?
ls will basically list all your current folders within the directory you're currently in. Now I'm in my run directory. So if I type ls within that, it will list all the files that are within that.
Okay.
Actually, your one shows cavity case. Mine shows cavity case fix daily. I'm not sure if it's
That because you must have, when you're installing, that time you must have copied the pitch daily also to check your installation. So you might have multiple files. So when you make this directory, you're saying cavity case, you've created this new one. You may have multiple files. So that's not a problem. Okay. Yeah. So once you're done with this, now we will copy a tutorial case. Okay. So if you see, I'll show you where all your tutorial cases are saved. So when you open your file explorer, you scroll down to the very end on the left side, you'll find a Linux. Okay. You click on this Linux, you open Ubuntu, you scroll down to OPT. Okay. Go to OPT. After that, within that, you'll find OpenFOAM 9. You click on that, and then you have tutorials. Okay. So depending on the type of simulation you want to run, you have various tutorials based on that. So instead of starting your case from scratch, it is always advisable to take a template folder from these tutorials and copy it into your run directory and then make modifications according to your application. Okay. Now in our case, we want to run a normal incompressible flow. So we'll take incompressible. Within that, we have icofoam. Within that, we want to copy this cavity case. Within cavity, this cavity. Okay. So we want to copy this one. Now, I'll show you two ways to do this. So you can, the first way is simple. You just copy this. You press Control C and you copy it into your run directory. So your run directory will be in your Ubuntu. This will be in your home. Okay. So in home, you'll have your name folder, OpenFOAM. Now, in case you have multiple versions, it will show. In case you have one, it will just show you one folder. That's not a problem. And you'll have run folder. Okay. So this is the file that we just now created, cavity case. Okay. So the simplest way is to directly copy paste it. But a thing in with Windows is when you copy, it will start creating these zone identifiers. That's a little bit irritating at some point. After some time, when you have to copy multiple files, it will create each file's zone identifier. So that is a little bit irritating. So you can do another way.
Sir, I have an issue here.
Yeah, what's the issue?
Yesterday while installing also in my system, there was no terminal for Ubuntu or Linux. So I have used one command to get the location of my files. I have used one command like explorer.exe.
Yes.
From there, I got the file. So if right now I can use that command to get the location of my files.
Yes.
Because in my system, I'm not having any like terminal for Ubuntu and Linux. Yesterday that was the problem.
Okay, you can do one thing. You can just now if you I think in your system you had multiple drives, right?
Yes.
So instead of copying it into your run directory, copy it to one of the drives and you just label it as say OpenFOAM or something.
Okay. So like to get that file itself, I should have to use that command explore.exe dot. Then only I can able to find that thing. In my whole system, I'm not having any Ubuntu or Linux portal itself.
Windows 10. Okay. So that only I'm saying that's why you in one of your drives you just create one folder. Suppose in your E or F drive you create one folder saying OpenFOAM, and you put all your run, basically whatever files you want to run, you place it within that folder.
So how to get that file, like how to get that folders initially? I have created one folder, but what are the things that I will be running? Simply you can go to Linux Ubuntu and you are getting that file, but I'm not able to get that file here.
Okay, so you're not able to get your tutorial file itself.
Yes, yes, yes.
I think you can change the directory to form hyphen tutorials. From there, you can just copy it, I guess, directly going into the directory.
Sir,
Hello?
can you please give the command to copy instead
Hello?
of
Yes.
folder tutorials?
Like what command should I give?
I mean like CP command to copy that from tutorials.
Yeah, I'll come to that. But first,
When we have installed, the tutorials were not copied, not installed in the OpenFOAM.
Yeah,
See,
you can
tutorials
directly
are
first go to the
there by
tutorial.
default.
But
Tutorials
I'm
you
not.
don't need to copy.
But where are the tutorials? I'm not able to find in my system.
Yeah.
Yeah.
So do one thing. Others, please, you all don't speak now. 1 minute. Who's this? Who's
This
having a
one.
problem? Can that
Mohammed
person
is
only
fine.
speak
Yeah.
up?
This Mohammed is fine.
So, see, Mohammed, maybe because you are running on a different version, so some of the commands may not be working, or some of the things that we are like Windows 10, so that might not be seen. So you can run completely by the from the terminal as well. But since for beginners the terminal is difficult, that's why we were showing from the GUI version. So what you can do is in your terminal just type TUT and press
TU.
enter.
So
Yeah,
what should I type?
TUT and press enter.
TUT.
Yes, TUT. Like Evan will show you.
Tutorial. Okay,
Evan is
tutorial. Okay.
demonstrating. So
Okay, okay,
TUT,
tutorial. Yeah.
so TUT directly takes you to the tutorials folder.
Yeah.
And from here you can copy whichever. So now if you want to view where this folder is, just type explorer.exe and .exe and then space and then dot. So it will
Yeah.
open that current directory in the Explorer. So
Yeah.
see,
Right now
it
I can
opened the
open.
tutorials.
Yes, sir. I've
Okay.
opened. Yes, sir.
So now once you do that, you have to copy which case. So now Evan,
income.
show them. So you
Okay.
have to go to incompressible, icofoam,
iCode.
cavity,
Yeah.
and in that cavity. So copy this folder. Copy the complete cavity folder, or you copy the contents.
Okay.
Okay, and then take it to wherever you want to create a run directory. Evan just demonstrate that one.
Yes, sir. Yes, sir. I
So,
did that.
so,
Yeah.
so Evan is demonstrating that. So these are for people for whom the Ubuntu file system is not seen in the Explorer. Okay. See, you can also whatever Evan is demonstrating, you can do that by running the command in the
Command.
terminal. So Evan will demonstrate that also if you are having a problem. So there are two ways of doing that. Evan quickly demonstrate both of them. Whichever is working for you, you go ahead with that.
Okay, sir.
Yeah.
Yeah. So the very first one, wait, I'll just come back to my run directory. So as I showed you, this was one way you can copy the files manually, or I'll just delete this one. I'll show you another way. You can do it through the terminal itself. Now, so this is my cavity case. So the second way is to write this command cp-r and you type $foam tutorials. Okay. Now what you're doing is you're saying copy the whole directory, that is cp-r. Then where to copy it from? That is your foam tutorials. Within that, we had an incompressible. Okay. So within that, we had incompressible. I'll just backspace this. Within incompressible, we had icofoam. Now within icofoam, we had the cavity case. And within that, we had one more cavity case. Okay. Now, we are saying that copy from the foam tutorials, within that in your incompressible, within that inside your icofoam, within that cavity and again cavity. And then you press a space and you say that I want to copy it now within this cavity case that we've created. So you type in the name cavity case and you press enter. So once you're done with this, now this cavity case, it was empty. I deleted the thing. So you see there's a cavity created. Basically, From the tutorial itself, it has copied that whole cavity case and placed it within my run directory into the new file that I've created. Okay, so I'll just show this command again for those of you who are typing. So can all of you do this? Has everyone done this?
Yes.
Okay, great. So now if you see within your file, it has not created any zone identifiers. So this is quite convenient if in case you're working on a Windows system. If you're working on a Linux system, directly copying it does not cause any issues. Okay. Now,
Sir, I also did that, but there was an issue. It is saying that missing destination file operand after this.
have you typed have you put a space and then typed cavity case?
Okay, okay. Before cavity case, there is a space.
Yes.
Okay.
Basically, you're saying copy from foam tutorials, incompressible icofoam cavity. Then there's a space, and then after the space, whatever name you type, it is saying copy to that folder. So
Okay.
whatever folder name you give, it will copy it within that.
Now it's done.
Yes. Okay. So now we have to enter this cavity case. So you type cd cavity case. Okay. You can always press tab. Once you're done typing half the letter, it will automatically fill in this case name. So you type.
Hello, sir.
Yes.
Actually, the thing is, even while going through the Explorer, I'm having the tutorials folder, but
Okay.
in that I'm not getting a incompressible folder specifically. I'm getting different folders like incompressible fluid, incompressible multi-phase viewer, and even after typing the command which you typed, that cavity case command just now, it is showing no such file or directory. So
Okay.
how to get to it?
Have you done your installation properly? Which version are you
Yes,
installed?
This is OpenFOAM 12.
Okay, so we are specifically told to install OpenFOAM 9 because of this reason only. Most of the files within OpenFOAM 9, between OpenFOAM 9 and OpenFOAM 12 are different. So to have that streamlined thing, that's why we are told to install OpenFOAM 9.
Okay, so is there any substitute I can use for
See,
icofoam?
you can check within your tutorials only. Icofoam will be kept in another folder. It won't be kept into the current one. The folder structure is also a little bit different. So you can just search that once in which file exactly is icofoam kept in OpenFOAM 12.
Okay, sir. Thank you.
Okay.
Hello. Actually, I am also facing the same issue, but I installed the OpenFOAM 9.
Okay. But you can't find icofoam.
No. It's showing that no such file or directory after typing the command. Manually, I can able to do it by copying and
Okay,
I
so
paste.
again the same thing. Have you put a space after this? Wait, I'll just lower the font. So you see there's a space between cavity and cavity case. Have you done that properly?
Yes.
Okay. Just check for any typos in case there is on.
Yeah, I checked again, but there's none. I typed exactly the same thing.
Okay, so if you can copy it manually and it is working, then you can go ahead with that also.
Oh, okay, fine.
Yeah, just make a note that whatever zone identifier extra files have been created, just delete those because while running a simulation, it may cause a problem.
Okay.
Excuse me, sir.
Yes.
Hello, sir. Sir, actually, I have to copy that cavity folder, and after that, what I have to do?
Once you've copied the cavity folder and you've pasted it in your new cavity case that we've created. Have you done that?
Cavity case. Where will I get it? Actually, we have installed it of my own, and maybe there was a problem. My files are in and here it is available in the user and share folder.
Rupindra,
it is not in the OPT. It is not in the OPT.
Your tutorials are not in your OPT file.
Yes. Then do I have to copy all the folders in the OPT?
No, you don't have to copy all the folders from your OPT. Within your OPT, you have OpenFOAM. So I'll show you. Okay. You see, this is your OPT file.
Yes,
Within
sir.
that, you have OpenFOAM 9.
Okay.
Within that, you have tutorials. Okay. Now, within tutorials, you have incompressible.
Yes,
In,
yes.
uh,
This
inside
file,
that.
sir, it is not in my OPT folder. It is in, I shared that one. It is it is in user, lib, then open form, then open form 24026 tutorial, incompressible. Yeah, you can check that
Yes, that is
message.
because you are on 240. On which version are you of OpenFOAM?
2406. Actually, last night I have installed because I was traveling yesterday. That is why I installed it in night by my own through YouTube video.
See, there is a lot of difference between 24006 or 2412 and between OpenFOAM 9, because they are, as I said previously in the intro also, that one is the foundation version, other one is the .com version, that is the ESI version. So most of the set of commands and file structures will be very different. So for this icofoam case, it is at least similar, but for the next one that you have a heat transfer case, in that some files are not present in the .com version. They have been removed or they've merged together. So
Okay.
for the heat transfer case, you might find it difficult.
Can I do right now? It's
Yeah.
possible to do.
See, you can do your simulation in both the versions, that's fine. But there are a set of files that won't be matching according to what I am demonstrating now. And the majority of the crowd here will have OpenFOAM 9 installed. That's why we've gone with OpenFOAM 9, because it's easier to learn as compared to the ESI versions, because most of the files are merged together and you won't understand basically what is going on. Okay.
What can I do? It means, is it
See, for this case, now you can continue what I'm showing. You can copy that file directly into your run directory and go ahead with it, because for this case, the commands are exactly the same.
okay?
Okay.
I have to copy this icoform means cavity folder to my run command.
Yes. Within your run command, you've created this cavity case. You created this cavity, you put it within that. Okay.
Okay. Okay.
Yeah.
Thank you.
Hello.
Yes, Ankit.
Sir, in run folder, where to copy this folder? Because I have not found the cavity case folder. I have followed the same step. First, I will do the directory, then ls, but I don't found in the run folder there is any cavity folder.
Could you just refresh your folder once?
Sir, actually, I have refreshed many times, but I could not find.
Okay, so within your run folder, you can just manually create one. You just you make a new folder, and you can do that way also.
Okay.
Okay. So can I go ahead now?
Yeah.
Okay.
Hello.
So yes.
This is Indrashis. I'm saying that I have also installed OpenFOAM version 12. So through WSL, but somehow the files are not matching. I mean, the case setup is not matching some of the files.
Yes, because you have installed OpenFOAM 12. We had told to install OpenFOAM 9.
Yeah. So I saw the website of OpenFOAM version 12
Okay.
and I installed accordingly through WSL. So after that, I am seeing that many of the case files are not matching. So what to do in that case? Do I need to install it is running in Windows only, but I haven't installed Linux or as a virtual machine separately as in the Windows as a host. So what to do now? Means I have not installed the OpenFOAM through Linux system. I mean, the Ubuntu is there, but not as a host in the Windows through virtual machine.
Okay, so Indras, you can just search on Google where exactly are the incompressible cases stored within OpenFOAM 12, and then you copy that into your run directory. Okay.
Okay. Got it. I'll see that.
Yes. So now we'll just go on ahead with the cases.
Hello, sir. Now, when I try to create folder in run, there is a permission denied, so I cannot create the folder. Why this occurring?
Ankit, have you tried doing mkdir in this command?
Yes, sir, I have done it. Same that, but after ls, they have given that cavity case it fits daily. So it is created or not?
So it is creating a pitch delay but not creating cavity case.
Okay. But when I try to do with GUI, that permission is not denied to create the folders. So how can I do it?
Okay, so you can type sudo and mkdir and then type the name of your folder, that is cavity case or something. Okay.
Okay.
After this, it will ask you to type in your password that you've put when you were installing. So just type in that password and it should create your folder. Okay.
Okay.
Yeah. Okay. So now we'll go ahead.
You say it again that command, please.
Which one?
That is sudo
mkdir and then cavity case.
cavity case.
Yeah. Okay. So now once you entered your folder, so if I type ls, you can see there's a cavity case. So we'll enter that folder also. So you type cd cavity, enter. Okay. Has everyone done this?
Yes. Sir, a minute I'm doing it, sir.
Okay. You can type ls once you're done. So you will find 0, constant and system. Okay.
Sir, OF9 is not found in my terminal.
No. In your cases, you will have only one version. I have multiple versions. That's why I've sourced OpenFOAM 9. You can directly start with the first command, that is this one, cd foam run.
Okay.
Okay.
Hello.
Yes, Indran.
Yeah, I'm saying that like when I first type the CD foam run, it is showing that no such file or directory.
Okay, so have you installed multiple versions or something?
Have I installed?
Multiple versions, or you only have one version, OpenFOAM 12?
No, before 12 I tried to install version 9, but somehow I was facing some problems. Then I installed the OpenFOAM version 12. But it's running in my Windows only, through Ubuntu WSL only. So
No, that is
somehow
not.
the file is.
So you can do one more thing. You can open the file wherever your folder is, your run directory. Like suppose I have my run directory and I want to, suppose I created the cavity case. I open this, go into cavity case. You can right click and type over here open in terminal. So it will open Windows PowerShell. After that, you can type WSL and it will directly open your Ubuntu at that particular directory. Okay.
Yes. Yeah, okay.
Okay. So has everyone done till here?
Yes.
Okay.
Yes.
So
Yes, yes.
first we will go to the block mesh dict. So if I type ls system and I type block mesh, okay, or I just type ls system. So basically it will list all the files that are within my system. Okay. So you see in my system, I have the block mesh dict. Okay. Yes, Ankit.
Sir, still I not created the directory. It's showing that cannot create directory, file is already exist, but I cannot found it from that. So what to do?
Ankit, can you refresh your system and check whether it
Sir,
is already?
I have already refreshed many times. Uh, there are lots of folder there in run, but I don't found the cavity case.
Ankit, you're in your run folder only, no?
Yeah.
Because in your run folder, there should only be at max two folders. Since you people have installed OpenFOAM freshly, you will only have one file, that is the test case that you all were testing your OpenFOAM as installed file. Aside from that, you should have nothing more.
But in my run folder, there are many folders are showing.
See, when you're copying your file, you have to copy it within Ubuntu home, and within that you have your name, open form. In that you will have in whatever your name you set, open form 9 or your name, and within that you'll have run. Okay.
Yeah. Okay, I will thank you.
So don't copy anything within this run. This run
Okay.
file is completely different.
Okay.
This
Okay.
one is for running OpenFOAM commands in the background. Those you don't touch. So you don't have permissions for these.
Okay. Okay.
Okay.
Okay.
Anything that you want to do will always happen within your home folder only. Because your home folder has been given access to do modifications to any files you want. The other files you don't have access, you'll have to every time type in your password so that you don't go and tinker around with all the background equations that have been set. Okay.
Okay.
Yeah. So once you're done with this, now in my system, I have my block mesh dict. Okay. So if you've installed gedit, you can open it through that also. I'll show you through this. So if I want to open it through gedit, I type gedit, I'll type system, and then I'll type block mesh dict. Okay. Now once I'm done with that, I press enter. It will open this small dialog box down. So it has opened my block mesh dict using gedit. In case you have problems with gedit, there's another way. I'd suggest all of you to do this way only, that open it, double click it and open it in Notepad itself. Since few of you all were having problems with gedit, you can go ahead with Notepad. Okay.
Hello.
Sir, can you show me the gedit code once again?
Okay, so you can type gedit, then you have system and block mesh dict. Okay.
Gedit and
basically you're saying that open that file that is within system and then the file name.
Okay, sir.
Yeah.
Sir, it is showing cannot open display.
Okay, that because gedit must have not been installed properly. That's why I'm saying that you open it in Notepad itself.
So where I'll get that file, sir? Gedit.
In your run directory, now whatever cavity case you've created,
okay,
you have your 0, constant and system.
Yeah.
So within system, you have block mesh dict.
Okay.
Okay, so you double click it, open it in Notepad. Over here you have it. Okay. Now I'll just.
Hello. Can you repeat
yes?
it once again after gedit?
After gedit. Okay. So see, instead of going through gedit, go to your folder, your run directory, whatever folder you've created. In that you have 0, constant and system, correct?
Yeah, I'm not able to locate the folders in my system, like in my users or in my local disk C. I'm not able to find where to get the folders, where to get the the OpenFOAM folders, all the tutorials folder.
See, that
because
will
I
be
haven't.
in your on the left hand side. You will have this Linux subsection down.
Okay. After
so
that,
you click on that Linux. For the click on Linux, you'll have Ubuntu 22.04 or whatever version you're using.
Yeah, I can see that it's Ubuntu as well as Ubuntu 22.04. So there are two Ubuntu's which I can see in my system.
Okay, so just see on which one you had installed your OpenFOAM. In case you must have installed it on Ubuntu, then it will be on that. Just check both. Within that, you will have your home folder. Within this home, your name, whatever you specified, and then you have OpenFOAM. Within that, if you have only one version, you will have.
Can you just repeat it, like the steps you have shown?
So you've entered your Ubuntu folder. Within that, you have your home folder.
Right.
So within home folder, you will have whatever name you specified.
Okay.
Then you will have OpenFOAM.
Yes.
Within that, you'll have again your name folder or OpenFOAM 9.
Right.
That you'll have your run directory.
Yeah. So run directory have, but I don't have the applications and the other ones.
No, the application and platform, those are the things that I've created. Okay. But in your case, you will only have the run directory.
So I have it.
Yes. So within run directory, you will have cavity case.
Yes.
Okay. Yeah. So within that, you have system, and then you have block mesh dict. Okay.
Cavity case. So after that, I will have the system, and I will
block mesh.
So after I put up all those comments that you have given in the
Yeah,
Power,
you
which I
can
can.
open it through gedit, but in case most of you might have an error with it, so it's better to go with notepad itself. Okay,
Okay.
so I will go ahead with notepad only, since the majority of people here will have notepad at least on Windows system. Okay, so I'll just show you how do you specify. Okay, so this is your typical meshing file or your block mesh file that you will have. So first you will start with convert to meters. Basically it will be set to default 1. 1 means that whatever unit you will specify, it is equal to 1 meter. So in this case, we specified it to be 0.1 meter. Okay. Because our domain, as I said, if you want to specify from 0 to 1, it is 0.1 meter. Let's see this one. Okay. It's 0.1 meter. So first you have the convert to meters, then you have your vertices. Now this is where you will specify your points in space. So I'll just show you the next one. So in block mesh, you will have to specify your points within basically it is comprised of hexahedral. So you will have 6 faces. So you'll have the back, one, front face, left, right, top, bottom. Okay. So the numbering scheme is you always go anti-clockwise for the meshing thing. So if I have the first point that is set to 0 point, basically at 0, 0, 0, that is my origin. So point 0 is my origin. From the origin, the next point I want it to be at a distance in the x direction at 1. Okay. Then the third point I want it to be at 1, 1 and 0. That is in the z direction, it is at 0. Okay. And then the fourth point I wanted, that is the third point, number 3, is to be at 0, 1 and 0. So from the origin in the y direction at a distance of 1. So the numbering scheme that is there, if most of you have used any or you have done any coding in C, C++, you know that the numbering always starts from 0. So it will be always 0, 1, 2, 3. So whatever numbering you're specifying, even though you're writing and you say it is 1, but then the background, it is coded in C, C++. So you will have this set as 0. So you'll have points 0, 1, 2, 3. Okay. So your one face has been made. Now the next one is a simple copy of that same 4 points that you've specified, and then you give it a direction in the y. Basically you give a small distance in the y direction. So in this case we've given a distance of 0.1. So we want the same points, that is 0, 1, 2, 3, but in a z direction of 0.1. Okay, so I'll show you this in this one. Okay, so you see this is the very first point. This is at the origin 0, 0, 0. Then we have 1 point, that is point number 1 at a distance of 1 in the x direction. Then we have point number 2, that is in the distance of 1 in the x direction and 1 in the y direction. So it will be in that space. Okay. And then you have this fourth point, that is in the y direction at a distance of 1. The same thing has been copied. The same one has been copied here, with the only difference being that in your z direction, you've given a small point. You're saying that extrude it in a z direction. Okay. The next syntax that you have is your block. Now within this, you will specify the numbering. Okay. So the way you've numbered it, that matters over here. So you will specify the syntax is first you have hex. After that, you will specify the numbering. So you see in the PPT, I will specify it as 0, 1, 2, 3. And then I want to again type that same thing as 4, 5, 6, 7. So you see here I've typed it as 0, 1, 2, 3, and then I have the front face, that is 4, 5, 6, 7. So what this will do is it will say that the back and the front face both have to be connected as a single unit. So that will make your one block. Now in our case, we only have a simple block. So it is a single, you have only just one single block. Okay. Then the next, this which is there, you will have your number of cells. Okay. So I am saying that in the x direction, I want 20 cells, and in the y direction, I want 20 cells. Now, since we are doing this simulation for a 2D mesh, so in the z direction, you will only give one cell. Okay. So this will become your 2D meshing. If in case you want to do the same case as a 3D geometry, then you will specify some grading in the third direction as well. Okay. And this one will specify your grading. So this simple grading syntax, this one will give you, basically you're giving a grading in your X, Y, and Z direction. You have kept it as 1. So in grading in terms, if most of you now, since you have done MTech and PhD, there are some few students, you must have used ANSYS, correct? So in ANSYS, you've noticed that you call that we call it a
Sizing?
not a sizing. Basically, there's a word for it in ANSYS. From F, I think it was.
Inflation layer?
Inflation, correct. Thank you. So in ANSYS, you have an inflation layer. So the same thing is in OpenFOAM, but over here, you specify it as simple grading. So there are multiple types over here. You have simple grading, then you have edge grading. All of those can be found within the documentation of OpenFOAM. I'll show you that also in a while. So here we've kept the inflation or your grading as 1 in all directions. So it's a uniform distribution. Okay. Then we have the edges syntax. Within these edges, if you have a curve or an arc, you can specify that over here. In our case, we have a simple box it is, so we're not specifying anything. And then last, yes?
Before you move, I just want to ask 2 questions.
Yes,
we are doing a 2D simulation, right? So
yes.
why are we putting 1 in the Z direction?
So the thing is that OpenFOAM is coded in a way that you can't give just an X and Y coordinate. It will compute everything in a 3D space. But in case we don't want to compute something in the 3D, in the Z direction in our case, so we will just give it 1 cell. So what it will do is it will take, basically it only has 1 cell in your that one Z direction. So it doesn't have any computing place or something to go into your Z direction itself. Okay.
Should we put 0? I mean,
if you put 0, basically, that, as I said, OpenFOAM is coded in that way that you have to give at least 1 cell. That is the bare minimum.
Okay. And another question is in the vertices part. So
Yes.
what we're doing is we are defining the control volume, right?
Yes, you are giving a control volume.
And in the part where we put 0.1, we are like telling which way the flow will go.
Basically, this is your XYZ coordinate. So over here, you're specifying in your X and Y plane, and then we want it the same replication in the Z direction, that you're giving it at a minimum 0.1 distance, since we are only doing it in a 2D.
Thank you.
Okay.
So in that direction, that points of 0.1 is nothing to do with the geometry size.
No, see, you can give it over here as 1 also, because it won't make a difference, because in the Z direction, we are only specifying 1 cell. So it is either way not going to compute in that Z direction.
Okay.
Hello.
Yes, Pooja.
Why there is 0.1 in convert to meters? It is something related to unit.
Yes, this is your unit only. So in our case, you see, we've specified the domain to be at a length, basically a length of 0.1 meters in all directions. So you can do this by converting it in the starting only, and then you can specify your units in normal, or you can keep this as 1 meter, but then you will have to specify over here 0.1, 0.1. Okay. So to save time, you can directly type in whatever units you want in this coordinate system of yours, and you can specify your actual units on top. Convert to meters 0.1.
Okay, and in the Z coordinate there is 0.1. So it is 0.1 unit in Z direction, or
It will
it
be
is something else?
0.01. 0. Basically you multiply 0.1 with 0.1 again.
Okay.
I will show you once I do the meshing in ParaView, so you can see then what I'm trying to say.
Can I just ask another question before you move forward regarding simple grading?
Yes, Prithul.
Yeah, so in ANSYS Fluent, so when we use inflation, like we probably use a y plus calculator using the first layer thickness or something, and then we plug in the value, right? So here in simple grading, you have put 1, 1, 1. I mean, what does that mean, or how did you calculate exactly?
Okay, so 1 is your uniform. Basically, your grading will work in OpenFOAM. It is, you have the last cell to the first cell, that is your ratio log. Okay. So this
Okay.
one works on a ratio system. So if in case I put 0.1, I am saying that my last cell will be 0.1 times my first cell. And based on that ratio, you compute that and you will get this 0.1. Does that make sense?
Yeah, I think, yeah.
Yeah. So we
like
kept,
it's a growth rate for the mesh, right?
yes, growth rate. In some
Oh,
software, you use a
Okay,
growth
yeah, it
rate.
is also
understood, understood.
Yes. So if you
No,
specify,
can you repeat the what you have said about the simple grading part for the
okay.
inflation layers, like how you are
Ivan, hello.
Yes, Ravi.
Yeah,
hello.
I just wanted to ask one thing. I mean, here we have made the control volume to be of hexagonal, means of something like cuboid, right?
Yes.
Had we wanted this to be of some cylindrical shape, so what would have been the command for that?
Okay. So you would specify your front plane, and then you would specify,
Yeah.
basically you would go in your X and Y direction, you will make basically a circle, and you're saying
Yes.
extrude it in your Z direction.
Yeah.
So that only, as I said, if you want to make any curves or arcs, you can specify that within your edges. Within
Yeah.
this section, you can specify, suppose you
Yeah.
say an arc, and then you specify the points. We will not go too much into this. So there is basically the entire syntax and everything
Okay.
is there in the
Okay. Okay.
documentation. I'll show you the
Yeah. Okay.
documentation
Thank you.
also, where you can
Thank you so
find it
much.
and what you can see.
Thank you so much.
Yeah, and somebody had a question on simple
About
grading
the
part.
simple grading. Yes, yes, yes,
Yes.
yes. Can you just repeat about the
Yeah.
growth of the inflation layer? How you are saying?
So
How
in
you
this
are?
case now, we specified 111, meaning that the entire domain, whatever cells are distributed, will be uniformly distributed.
Hmm.
Okay. Now, in case I specified it as 0.1, you would do some calculations saying basically your simple grading works on a ratio system. It is a ratio of your last cell to your first cell. That is the current ratio. That is the calculation you do. Based on that, you can specify whatever number you get. Like suppose I say that my last cell I want it 10 times large compared to my first cell. So I want the first cell to be smaller and the last cell to be larger. Okay. So I will just run a simple calculation of say 10 to 1. So if I want my last cell to be 10 times, I will specify here 10. So
And
then
this
the
is the
grading
last cell that you're talking about in the X direction.
in the X
And if I want,
direction. Similarly, if you want it in the Y direction, you can put the grading over there also. Okay.
okay, so it is the so it represents the how I want to inflate the or like refine or like the machine
Yes.
in that particular.
So you see, this one is a simple geometry. Now in the next case, when you have a turbulence flow through a channel, that time Manzil will show you how to apply grading and everything. So all of these you will understand sooner in the whole workshop. So don't worry about that. I'm just giving you an overview of how block mesh is working.
Is it possible to give a particular first layer height here?
In this case, you want?
Yeah.
You want to add a grading.
Add a particular first cell height.
You want to add a height to the first cell.
Yeah, I will calculate my y plus and then add a particular y first cell height to it with a growth ratio of 1.2 something.
Okay. So
is it possible here, or
but then I think you'll have to then adjust the control dict also accordingly to match that, because I think it might give an error later if I give a growth rate, because you can see there are only 20 cells and I'm saying to distribute it around 0.1 meter. So if I give in the X direction, it might give some floating point error or something because of the discretization and all that. So we'll keep it as uniform only. In the next case, you can ask Manzil to also do that, because he'll be showing you how to give a growth rate accordingly and calculate your y plus values and everything.
Thank you.
Okay. Yeah.
So like this will create a uniform mesh of thickness, maybe like of 20 mesh in X and Y direction, right?
Yes, it will create a uniform mesh. I'll show you all the mesh also once we
Okay,
are
sir,
done with
one
this.
more question, sir. One more question. Like
Yeah.
in other software, if here we are doing it dealing with Cartesian coordinate system.
Yes.
So if we are doing like one person asks if it is cylinder, so
Hmm.
if there is something to define cylindrical coordinate system, and from there, like if like assign coordinate system itself, if there is some command is there.
Assigned coordinate system as in?
Here we are dealing with a simple rectangular flow domain
Yes.
with a problem. Like if it was like some cylindrical system, and from there, how we'll define that thing?
So that only you specify basically to make a cylinder, you will have two circles and you're basically joining those two circles, correct?
Yeah.
So similarly, in your x and y coordinate, you will make a circle. Okay.
Yes.
So if you just break down that circle, it's like just a square with some curves.
Okay.
An arc. Okay.
So all those things that has to be done in the edges, right? Inside
Yes.
the edges.
Yes. You specify within edges an arc, and you specify the point that now I want between point 0 and point 1, I want an arc, so that I can specify within that. See, wait, I'll show you all. So if in case I type OpenFOAM 9, so if you see in the foundation version OpenFOAM 9, on top you have resources. You can check the user guide. So over here you can see anything, like if you want to find out something about block mesh or something, meshing description. So you can read through this. Each and everything is documented properly. So in case you want to find any syntax also based on the version also you want. So I can click OpenFOAM 9. I can see which types I want. Okay. So you can read through this. You can just type OpenFOAM 9. On top you have your documentation. You can download also the documentation. Okay.
Okay. That's like one more doubt. Like if my problem itself is dealing with cylindrical coordinate system, like if there is some pore system is there, like some cylindrical systems, accordingly equations will be dealing with r, theta, and z coordinate system. Like our equation will be modeled that way only. So how to deal that thing?
Basically,
In case of x, y, z, I'll be dealing with r, theta, and z coordinate.
So you're dealing with the spherical coordinate system.
Yes, cylindrical coordinate actually. So like r, theta, and z. Yes.
But then you can break that down into a normal Cartesian coordinate, right?
That would become difficult for like governing equation itself will be written in that way only.
Okay.
In cylindrical coordinate.
So see, if your geometry is too complex, you can always go with snappy hex mesh also. That is another. It's a little bit advanced meshing tool. It's part of OpenFOAM only. What it does is you will specify one normal base mesh, and within that you put your complex geometry, and it meshes it according to that.
Okay.
Yeah.
Can I import geometry from some other sources like from ANSYS or AutoCAD?
Yes, you can do that. See, ideally you can always use block mesh because it's an inbuilt tool, and with block mesh you have many other utilities that you can do, like in case you want to do some refinement while your simulation is running, so you can use adaptive mesh refinement and all those things. Whereas if you import an ANSYS mesh, that ANSYS mesh will be written according to ANSYS, right? So the background, whatever codes are written, it won't understand. OpenFOAM won't understand how to refine the mesh or something according to that. So you're fixed with that one fixed mesh.
Oh, yeah.
Yeah, but
So
but you
if
can always
geometry is very complex,
so that
like
only, as I
bed
was
with
saying.
things varying, then
Yes.
how to make here geometry?
So that only, if in case you have a very complex geometry, you can always create the CAD file within any software. If in case you're making it in ANSYS also, you can always do that, and then you can use Snappy Hex Mesh to make a mesh for that.
Okay.
Okay. So for Snappy Hex Mesh also, we had held a workshop last year in November. So you can check, it's on YouTube also. You can check how to go about using Snappy Hex Mesh.
Okay. Thank you.
Yeah.
Hi, Ivan. I have a question.
Yes, Asma.
So it's when you said simple grading is about the inflation layer.
Yes.
So when we is it in terms of a 2D domain or is it in terms of a 3D domain? Because let's say like we have a blockade that's located in between the entire computational domain, right?
Yes.
So if you're applying here, though we have said like it's an uniform sort of a blocks that you're creating in there, 111. But if you increase like a ratio of 10:1 ratio, you're basically applying it to the background or the block mesh itself. So what is the use of applying it to a block mesh rather than because the inflation layers have to be created on an object so that you can capture the gradients, right?
So you have a geometry, you're trying to say that you have a geometry within that domain and you want to mesh it closer to that geometry, correct?
Yes.
Yes.
But
So
now the question is like, why are we trying to apply that simple grading or the inflation layers on the background mesh or the block? Because this is the entire computational domain here.
okay. So now in this case, it's a simple block. Okay, we don't have any geometry within the domain itself. So in case you want to even have a coarser mesh towards the edges and you want to have it fine towards the center. So as I said, there are multiple ways of doing that. This is the simplest one. Okay. So simple grading. You also have edge grading and you have multi grading. So in edge grading, you can specify a particular edge and you can say that I want a grading of this much on this edge, whereas on the opposite side, I want a grading of say suppose 2 or something. So that way you can do using edge grading. Whereas in multi grading, if you have a single block, you can define on that. Basically now over here we're specifying 1 1 1. So in the x direction, we're specifying a uniform 10, suppose 10:1 ratio. Whereas in multi grading, you can specify that towards the left, I want these many cells and I want only a set of grading for this much. Basically, I want a grading of say 10:1 on the left direction, and I want 10:1 on the right direction as well. And towards the center, I want it to be a little bit coarse or fine. So you can do that using multi-grading as well. Basically, what it does is it will allot a percentage of cells. Like if you have say 100 cells and you specify a percentage of 50%, so it will say that 50% is towards the left, 50% is towards the right, and then based on that 50%, you can give a grading to those 50% cells only. That you can do using multi-grading. So that also documentation is there on the OpenFOAM official website, so you can always download those and see that.
Okay, got it. Thank you.
So basically here you told about the inflation layers in the simple grading in the block mesh because this is a simple geometry, right?
Yes.
And so there is no like specific requirement to inflate the layers for in the close proximity of so these simple geometry. That's why there is no requirement to do such things in this block mesh. But I can do it in snappy spaces. Okay.
So once you're done with the block edges, everyone has understood that. Then you specify your boundary. Okay. Now this is where you will specify your patch names. So in this case, we have a moving wall. Now in the patch name, I can go back to this one. So the way you name your patches is suppose I take this right side patch. Okay. This one. And if I use the right hand thumb rule and my thumb is pointing outward. Okay. So, and if my fingers are curling that, so I will label the whole thing according to that. So if in case my thumb is pointing outward and my fingers are curling around my thumb, basically around my thumb. So I will label it as say suppose 1, 2, 6, 5, if I have to label this face. Similarly, if I want to label this top one and my thumb is pointing outward, my fingers will curl in the anti-clockwise direction. So I will label it as 2, 3, 7, 6. Okay. So as you can see in the moving wall, the top part that we have, we've labeled it as 3762. That is in the anti-clockwise because my thumb is pointing upward. Similarly, the fixed walls is specified 3. That is these 3. 1, 2. That is the right side, bottom, and the left side, accordingly to that right hand thumb rule. Okay. So that is the way to label your boundary patches. Also over here within type, if it's a wall, you can specify it as wall. Whereas if you want it to be a patch, that is you want to put some custom boundary condition on it. Say I want it to act as an inlet or an outlet. So I will just simply type patch. Okay. So there are multiple types also. Those also are mentioned in the document itself. So you can always read that. Okay. Front back, if you want, in case it's a 2D domain, if you do not specify any of the front back faces, it will OpenFOAM will directly take those as default faces and it will put that into one. Basically, it will create one patch saying default faces and it will start running it. Your default, basically front and back, since it's a 2D domain, we will take it as empty since we don't have to compute anything in that. Okay.
Could you please explain the front and back part?
Okay. Now, in case you have a 3D domain, okay, I'm taking a simple box. I have the left side as an inlet, right side as an outlet, and everything around it is a wall.
Yeah.
But in a 2D domain, if I want to compute, say, a channel, I am saying that the left is an inlet, right is an outlet, top and bottom is the walls. And in the Z direction, I am extending it to up to infinity in both the directions. So technically, the front and back will act as an empty patch because we are not giving it any wall condition. If you give it a wall, it will start computing the drag and everything, basically your boundary layer separation and all that. All those things will start being created over there. So we'll start computing that also. If you give it as empty, it is saying that within that direction it is empty and you don't have to compute anything in that.
Okay, understood.
Yeah. So this is your block mesh dict. So once you're done with this, close this. Yeah. Next you have is your control dict. I'll go a little bit fast because the next session also was supposed to start at 12 o'clock. So within this, you have your application icofoam. Okay, so over here you have your icofoam start time, whatever, it will start at 0, and I'm saying to end it at 0.5. Over here, you will compute your, basically based on a current number, you will specify your delta t. So those sets of calculation you will run before you run your simulation, and you specify your delta t accordingly. If you give this number too high, your simulation will crash midway or it will not compute itself. So keep in mind when you're doing any simulation, if it's too complex, obviously your delta t will be lower. If you're going with a finer mesh, again, it will go lower.
So delta t is a time step, sir?
Yes, your time step.
Okay.
Then you have your write interval. After how many iterations or write time, like you're saying, delta t, after how many of those you wanted to write some data. So I am saying after 20 of those iterations are done to write one file. So that you can do using this one, write interval. Write format, ASCII, runtime, all those are always kept at default. Also purge write over here, that is there in case you're running a very heavy simulation, a steady state simulation, and you're only you're only interested in the last result. You don't have to see any of the intermediate points or anything like that, intermediate results. So you can specify this as, say, suppose 1 or 2. So what this will do is it will, suppose now if I'm saying after every 20 iterations to write a file. So if I have a file from say 0 to 100 and I give a purge write of say 10. So once it has written 10 files, the 11th file that it will write, before writing the 11th file, it will delete the very first file that it had created. So at a time, it will only save up to 10 folders at the end, the last 10 files. So that you can do using purge write. Okay. Usually it is kept, if you're doing a transient simulation, you will obviously need all the files that you've been computed and written to get your contours and everything. But if it's a steady state simulation, then using purge write is advisable because it saves your storage space also on your laptop. Okay. So this is your control dict.
For transient simulation, what should be that purge write? Like, what's the value of purge write?
Typically, it is kept to 0 only. But in case you have a steady state simulation or you're having some storage problems or something, you can do two things. If you have a storage problem, you don't have enough storage in your laptop or something, you can put your write interval to a higher number. So it will start saving the files at a higher number. That way it is. Okay. After a lot of iteration, it will start saving only one file. Or you can use purge write to only save, suppose, the last 10 files or the last 5 files in the simulation. But in transient simulations, it's always kept to 0 only because you will need all the files that you've computed.
Okay.
Okay. Yeah. Then we have FV schemes and FV solutions. I won't go too much into these. I'll just give you an overview. Basically, over here, you specify which set of equations you're solving, all of those parameters. In FV solutions, you will have your basically which solvers and all you're using, how you want to solve it, which equation, that basically whether it's the pressure equation or something like that, pressure based solver and all that. Okay. Then you have your constant folder. Again, in this one, you have all the properties that will remain constant. Okay. So now in this one, we have a new, that is your kinematic viscosity. We set it to 0.001, that is default. If in case you want to simulate for air, you change it accordingly. Okay. And then you have your 0. So within this, you'll have your U folder and P folder. U is your velocity and P is your pressure. So again, in our case, we've put a velocity, constant velocity for the moving wall at 1 meter per second. Okay. So that's why we specified it as 1. So once you're done with setting up all your boundary conditions, in this case, we're leaving it the same.
Initially, sir, like we have put some scale of 0.1. So that will be considered here while putting the boundary condition. That magnitude will be multiplied by that. Okay.
No. See, basically, if you see the top section over here, this is your dimensions. So your dimension, this one will set basically this 1 stands for meter. Basically, 1, it is your this. For pressure, it is your pascals, meter.
SI unit.
Yes, your SI unit system. So over here, it is meter per second square. So this one is your time, this one is your length, and this one is your time. So this one won't be converted according to that. So it is running at pure 1 meter per second itself. Okay.
I even have one more question.
Yes,
Asma. Okay, so what is the difference between internal field and a boundary field? So you have mentioned there is an internal field over there with an uniform 000. So what is it actually doing?
Okay, so in an internal field, you're saying that so already there's some flow going on. Now if I specify over here as 1, I am saying that the internal field is already set to 1 meter per second, and whatever values I'm giving now, the moving wall, it is starting at 0.1 at 1 meter per second. So you can basically it just saves you a little bit of computational time, but it is negligible. So if you have if in case it's the tutorial case, they usually leave it at 0. But in case if you have a temperature, let's go for temperature. That is a more better example. You have your domain that is at, say, suppose you're saying you want to set it at normal STP at 30 degrees. So I will convert that to Kelvin and I will say that it is around 293 Kelvin or something. So I will specify that my domain itself is set to 293 Kelvin, and whatever additional temperature that if I'm giving it from the left or right, as I'll show you in the conduction case, in that way specifying the temperature, and that internal field is also already set. So all of these I will explain that time also. So don't worry about that. Okay.
Okay. Thank you.
Okay. So once you're done setting up everything, so the first thing is in doing your entire simulation, first you will create your mesh. So that you will do using the block mesh command. Okay. So everyone just type this in. And type block mesh and then you type enter. Has everyone done this?
Yes.
Okay, great. So once you're done with your block mesh, then the next thing is you want to run the simulation. So in our case, we're using the solver icofoam. Basically, icofoam is just your incompressible foam. It is just a solver made to compute incompressible flow. Okay, so I'll type the solver name icofoam. Okay. Has everyone done this? Then you type enter. It will start running a simulation. Now, since end time was quite small, so it has computed instantly. So you see the current number over here. We specified the delta t accordingly so that it does not cross current number 1. Okay. Now, everyone has done this?
Sir, can you please rewind it, sir?
Icofoam.
Yes, sir. Sir, from the block mesh, sir. So this is from the.
So you can always do block mesh and then run that. Done?
Sir, it is showing block mesh command not found, sir.
Are you in your proper? Okay. Are you in your proper file? You have to be in your cavity case only. You don't have to be within system or anything.
Sorry, sir. Not in the system.
Okay, so if you're not in a if you're in your system folder by mistake, you can always do cd ... to get out of the folder. Okay.
Okay, sir.
Yeah. Basically, cd ... is to go one step behind, whereas cd and your file name will take you within that folder.
Okay.
Okay. So once you've done block mesh and icofoam, you can visualize your data that you've got using parafoam. Okay, I'll show you both the ways because I know some of you all have problem with paraform. So the first way is to show it through typing paraform simply within this. Okay. The second way to do, for those of you who have problem with paraform, you type touch dot, say suppose result, not dot, sorry, touch result dot form. Okay. So this will create a new file. So you see over here, these are your run files that when you run, it will start writing all the data. And when you do that touch command, that time it will create one result folder. Okay. So for those of you who have problem, then you launch your paraview manually and then you drag this and you directly put it within that. Okay. Yesterday, I think 3 of you had problems with that. So we had
Yes,
shown you how to do that. Okay.
yes.
Yes. So I will.
What's the commands are like touch result.form?
Yeah. Result is basically whatever name you want to give. Over here, you can type in your name as well if you want.
Hello, sir.
Yes, Aditya.
The thing is, there's a username is written in green, right? At the starting of every command.
Yes.
Okay. So I'm not getting it. I don't know why it has gone.
Okay.
So,
So
what should I do?
okay. So can you just restart your terminal and see whether that solves the problem?
Okay, but will these commands be gone or
No,
whatever
commands you've typed, you can always press the top arrow key. It will always save all those previous commands that you ran. So you can always press the top arrow key to see which commands you ran previously. So you see, I started from mkdir. Yes.
Yeah, I'm a bit of lagging behind because I was following the how you were working on, but I am actually in my run folder, but somehow I'm not able to create the incompressible directory. So what is the actual directory? Can you tell me?
Okay.
Like,
So if you're in your run directory,
folder.
if you're in your run folder, you can just manually create a new folder. Say suppose I want to create cavity case, you click on folder, create a new folder, then you go within that folder. So I'll show you where your tutorial files are saved. So if you're in Ubuntu, you have Linux Ubuntu. Within that, you have an OPT folder.
Okay, those things is not there because I haven't still put up the commands over in the WSL. I mean the on PowerShell.
I didn't understand what you're trying to say.
I mean to say that like I haven't put those commands in my PowerShell because those are not there in my cavity folder, cavity case folder.
Okay, your installation has been done properly. Because if your folders and all are not
OpenFOAM is there in my VirtualBox. OpenFOAM is there, run is there. Then after that, cavity case and feeds daily. So when I click on cavity case, the folder is empty.
That because you must have not copied that. So that way I'm showing you how to copy it. You can manually copy it, or you can type in this command. Basically, you open your terminal. I'll show you. I'll open a new terminal. Suppose I'm in my run directory. Okay. I'll open this in terminal. Now I've opened it using PowerShell. I typed WSL. That will take me into the Windows subsystem for Linux. So as you see, I'm already in my run directory. I'll just type openform9 because I have two versions. So if I do just clear, yeah. So you will be at this particular point, okay? So you do cd cavity case or whatever name you specified it as, okay? And you do enter. Okay. So now you type in this command cp-r $foam tutorial. Okay. After that, you type incompressible. Within incompressible, there is an icofoam folder. So you will go to that icofoam folder. Within that, you have cavity. And within cavity, you have one more cavity case. So we want to copy this entire cavity case within the current directory we are in. So you can just put a full stop. Since we are already within the cavity case, if in case you were directly only in your run directory, you could have typed cavity case and all that. But then now since we already entered that cavity case, you just put a full stop. So the full stop means that you're copying this whole, basically this folder from this path into the current directory. That is your full stop. That is this particular
So
directory.
I will not write cavity case.
No, don't write cavity case because you're already there in your cavity case, right?
Yes. So I will put a dot over there.
Yes, you put dot. The
What is the
same
use?
command.
What is the usage of this dot?
The dot specifies that you want to copy whatever files you specified in that path in the place that you are currently there. That is your case. This basically this folder that you are already in.
Yeah.
Okay.
So now I will.
Yeah. So you can just run
But
block mesh.
it's saying that no such file or directory.
Just check your this if there's any typo or something.
Tutorial, right? Not tutorials. Tutorial, incompressible icophone, cavity
Is a
dot.
OpenFOAM tutorials S. Okay. So I'll just show the. I'll go ahead with the result. So we type parafoam.
Excuse me, sir.
Yes.
I actually typed the command name blockmesh as you mentioned, but then I'm getting a foam IO error instead of the result. It's showing it cannot run the command. It says some IO error.
Block mesh.
Yes, block mesh and for icofoam, both of them.
Which version of OpenFOAM you're on?
9 only.
9 only, no?
Yes.
And you've not made any changes in block mesh or anything?
No, as you mentioned how to change whatever things, then the block mesh, the same thing only I've done.
Okay, because in block mesh you don't have to change anything. So you didn't make any changes, right?
No, I didn't make any changes.
Okay. It's giving an IO problem.
Yeah.
So when you're typing block mesh, it is giving that error.
Yes, block mesh and icofoam, both of them.
Okay. Just do foam clean case. Type this command foam clean case. This will basically just clean the whole case. If in case any previous data or something was written in it, it removes that.
Okay.
And now type block mesh and see.
Fine, I'll just check it, sir.
Yeah. Okay. So we'll go with parafoam. So since all of you all have already brought your file into parafoam itself, paraview. So on the top left corner, see there's a VTK block color written here. So you can click that drop down menu. You can click on U. Okay. And then I click the play button. Okay. So you can see, since this is a moving wall, but now through this you can't understand exactly what is going on. So I'll show you a way to plot the streamlines. So just below your this U, there is this streamline of.
Excuse me, sir. Can you repeat it again, sir? After opening the parafoam.
Okay. So after opening parafoam, you typed apply over here. There was one apply button. It should be bright green if you've not already clicked apply.
Sir,
okay.
but it's not working, sir.
What is the error that is giving?
Sir, in my pipeline browser, only built-in is appearing, sir. No cavity.open form. Sir, I can't see any cavity.open.
See, wait. You're using this only command, no? Parafoam.
Yes, sir.
Okay, so when you're typing parafoam, this field is showing?
No, sir.
Okay. Have you run your case? Have you done icofoam?
Yes, sir. I have done icofoam, sir.
And in your case itself, can you see these kind of things? If there are some additional files written?
So, one moment.
Just one thing, like I'm in a cavity case, but somehow I'm not able to go back to my cavity folder by giving cd dot dot.
Okay, so you can't go back to your cavity.
Yeah, because I'm in my cavity case run now in my PowerShell.
It's cd space dot dot. Okay.
cd space dot dot. Sorry.
Yeah. Okay. I'll just go ahead with, for those of you who've already done this. So you click the apply VTK blocks and you have U, and then I click the play button. Okay. Now if I want to plot some streamlines of how the flow is going about, So there are multiple ways to do that. Below your U file that you've just clicked, below that you'll find this icon. It says streamlines. You click that. Okay. So this one will first plot over line, but we don't want a line. We want it to plot over the whole domain. So you do this, you change. So within down here in seeds, you will have the seed type. You click on point source. It will generate this one small circle like spear like thing. Okay. Has everyone got this?
Yeah.
Okay. Then you can change the radius of this spear. Now we want this spear to completely cover this whole domain of ours. So I'll specify it as 0.1 or something. Yeah. So 0.1, you see it is covering the whole domain of ours. Okay. On the left side, you have this small icon to show spear that you can switch on and off. I'll just switch it off. And then below that, you have number of points. Okay. So you see, if I'll click apply now, if I keep this number of points as 100 and I click apply, it will only make just these many lines. So specify this at around, say 10,000 or 1 lakh. I put that. You see, it has created some nice line, streamlines. I'll just put it to 1,000. You see, it has created some nice streamlines of how the flow is happening. So since these sections were a wall, I can show you that also. So you see, this was a wall, the sides, and this top wall is moving. So as it moves, there's some circulation that is happening within this cavity case. Okay. So there's one more way. You can, beside the streamline only, there is this glyph also. Yes.
Excuse me. Can you please explain again from the strip? Yeah.
Okay. From streamline, I'll just delete this. So everyone has this. So over here on top, just below your this U that you have clicked, there's a streamline tracer. You click that. Okay. Subhash?
Yes, yes. Yeah,
okay.
please.
Yeah. So then below the apply button, you see the seeds is there.
Yes.
Under that, you have a high resolution line or you have point source. So click on point source.
Yeah.
Then click on this, the radius that is there on spear parameters. Okay.
Okay.
And set it to 0.1. Press enter.
Okay.
If you want, you can keep the spear. I'm just switching off the spear. There's a on off button over there for spear. Okay, I'll switch it off.
Basically, this defines the area where we will have this, you know, the path.
Yes, correct. And the number of points that you want to specify, just specify it as around 1 lakh or 10,000 or something like that. Okay, you specify it as 1 lakh. 1 lakh will make it too many. You specify it as around 10,000. So this way you can get your streamlines.
Okay.
I'll show you one more way in which you can help. It will help you visualize how your flow is going about. Yeah. So you see, the top wall was moving. So based on that, how the flow in the whole cavity is moving around. So you see there's a circulation. So the flow is happening here and then it moves in the circular direction.
Can you just repeat the vector part, please?
So see, beside the streamline only, there is this globe-like thing. That is your glyph. Okay.
Got that.
Yeah. So you click on that and then in orientation, you click on U. And in scalar array, you click on no scalar array and click apply. So basically what this orientation will do, it is saying that put the vectors according to how the flow is happening. That was for U. And then scaling, basically if I put scaling also to U, it will basically make these arrows. If there's a high velocity, it will make the arrow larger. If there's a lower velocity, it will make it smaller. Okay.
this is kind of velocity vector that is
Yes.
plotting. Okay.
Hello. So,
Yes.
can you just show your like the PowerShell ones like, to get the comments? I missed some comments. I think after I didn't run the so yeah before in the cavity from the cavity case. I just want to take the screenshot.
Okay, so you want the cavity case, right? So first, once you open your cavity case and everything, you type block mesh.
Yeah, that is done.
Then after that, you type icofoam.
Okay, wait a second. No, before this, like in the cavity, I have typed gedit system block mesh dict. So it opened, but it was showing some warning.
That warning it will show that is normal.
Okay, so after that?
After that, you close that gedit and you type block mesh.
Block mesh, okay.
Yeah. After block mesh, you type icofoam.
Icofoam, okay.
And once you're done typing icofoam, click type paraview, parafoam. Yeah, basically this command.
So all this is in the same cavity folder, right?
Yes, everything is in the cavity folder only. Okay.
So it's showing no such file or directory.
Just check.
You mean to say like block mesh and icofoam, parafoam all separately I need to do?
Yeah, the commands are all separately.
In the bash, block mesh is showing that no such file or directory.
You'll have to just once check your directories whether it is proper and you're in the proper folder.
Yeah, I saw that it's in cavity in system. It's in system.
Okay.
The block mesh dict.
So you don't have to go within your system. Go out of your system. Do cd dot dot cd space dot dot.
Okay.
And now you will be in your cavity folder.
But I can see in my PowerShell that I was already in the cavity folder.
Yes, so you have to be in your cavity folder only. All the commands that you're running, that will be within your cavity folder itself. You don't have to go within your system folder and type those commands.
Can I open a new PowerShell and from the cavity folder itself?
See, in your PowerShell, you've typed WSL.
Yeah, it is.
Yeah. Now it is open proper Ubuntu environment, open form environment. Now once you go into your cavity folder, run the set of commands that I told you, and through that it should run fine. Okay.
Okay.
If someone else had a doubt?
Sir, I was trying glyph.
Okay.
Sir, I do have the same
mismatched attributes. U is a point attribute, whereas view is a self.
It's okay. You can always see some videos on glyph and all. I was just showing you how to basically to help you all visualize the whole flow, how it is going on. You don't have to necessarily do that. Okay.
Thanks.
I'll just show you all how the meshing was. So you see, this is a uniform mesh, and you see in the Z direction we've only given a distance of 1. So because we don't want to compute anything in that Z direction.
Excuse me, sir.
Yes, Siddharth.
Yeah, the block mesh error is still not rectified. Actually, it's showing that there's an unexpected line on an unexpected word on line 19 or something of that sort.
Okay, so you can open your block mesh dict and go to line number 19 and see if there's anything typed wrong or something.
Okay, that's the only error, right? Because I checked there also, but I don't seem to see anything.
Okay, just confirm if there is some semicolon or something missing.
Okay, fine. I'll just.
Yeah, because just check, because like normal C++ code, if your semicolon or something is missing, it will give you an error. Sometimes by mistake, if you backspaced it or something, that might be the problem.
Excuse me, sir. So actually, I'm running with that open form. Mine is 2024 actually. In that folder, that cavity and in cavity, it is a block hash dict folder is there.
Yes.
Whatever you show. Okay. I'm running with this command, that block mesh dict. It won't.
No, you don't have to run block mesh dict. You have to run block mesh.
Only block mesh.
Yes, only block mesh.
Can you just scroll up to show such that you can show the command in the cavity? Yes, in the cavity folder for the block
Can
mesh.
you?
Okay,
Yes,
okay.
yes. Hello.
So you type block mesh.
Yeah. Then after that, I have to run.
Yeah. After that, if you want to run your simulation, then you type icofoam.
Yeah. Then.
So
Then after that, paraform.
yes, after that parafoam.
Hi, Ivan. Another question.
Yes, Asp.
So, do we have to be case specific when we are trying to type in block mesh? Could our M be uppercase or could it be lowercase? Is it acceptable to do it anyways, or does it have to be specifically uppercase?
No, the thing is that in open form, you will always have the very first letter small, and then if there's a new word like I have para and then foam, then the word that is following another thing, we always capitalize it. So even in block mesh, the M will always be capital. In icofoam, the F will always be capital. In parafoam, also F will always be capital.
So it is sensitive to the case,
Yes,
right?
because in the
Okay.
yes, because in the back end they've typed it as when you type block mesh, that time only the meshing will happen. So that keyword is already specified in the back end. So you can't just type anything you want.
Okay, thank you.
So now, right now, I'm in ParaView.
Yes.
Can you say it again, please?
Yeah.
Sorry.
Okay, I'll show you again. In parafoam or paraview, you can click this green apply button on the left. That will load your case.
Yes.
Okay. And then you can click on the top left corner. You see this VTK blocks. You click on U. And then you click the play button. So you can visualize your contours. Okay. Now, if you want to see some streamlines, just below that U, you have this streamline tracer option. So you click that. Okay.
Maybe mine is somewhat different to yours.
Yeah, that the version of paraview might also make a difference. So you can always check these because as long as you can see your contours and all, that is fine. Streamlines and all, it must be kept somewhere else in your version. So always you can see some videos or something. Those are readily available always. So see, there's another way you can open the streamline. On top, you have these some options. You have like file, edit, view. Can see those?
Yes.
Yeah. So click on filter. Okay. And on filter, go down to alphabetical.
Okay.
See, on alphabetical, then it will open all these other options. So you go to S and you see the stream tracer. You can click from here also. Okay. So once you click on that, you can scroll down. You can see seeds. Can you see the seeds option?
Yes, sir.
Yeah. So instead of high resolution line, click on point source. So it will make this sphere appear. Yeah. So you can change the radius of the sphere. There are the sphere parameters. You change it to 0.1 and type enter. So it will make it large. Okay.
Yes.
So then you can switch off the sphere if you want. If you want to keep it on also, you can keep it on. Below the sphere parameters, there is this number of points. Okay. So change that to around 10,000. Okay. Once you're done with that, click apply. It will make your streamlines.
Thank you.
Okay. Yeah.